Hello, everyone. Today we're going to talk about graphing exponential functions. So first, we're going to recall that linear functions are characterized by having a constant rate of change. So a linear function looks like y equals 3x plus 2, and that would have a slope of 3 and a y-intercept of 2. And the slope, remember, is our constant rate of change. Now let's consider exponential functions. So exponential functions, we're going to consider f of x equals 8 times 2 to the x. So we're going to create a table, and we're going to circle our y-intercept. So now to create a table, what we want to do is we want to think about the x can be any value that we want, and then we're going to substitute to find f of x. So I'm going to do -2, -1, 0, 1, 2, 3. Now, to create our table, what we're going to do is we're going to put the exponent in for x, or the x value in for our exponent. So it's 8 times 2 to the -2. We do our exponents first. So that's 8 times 1/4, which equals 2. Now, we can do these all by hand, and I want to show you how to do them by hand. However, most of the time I'm going to use my calculator. So I'm going to go to y equals, I'm going to do 8 times 2 caret to the x. And then I want a table. So I'm going to do second graph to see my table. And I can use the arrows to see more of my table. So you see -2 does indeed equal 2. -1 is 4. 0 is 8. 1 is 16. 2 is 32. And 3 is 64. So our y-intercept is 8, because the y-intercept is always where x equals 0. And hopefully you notice that we do not go up at a constant rate. However, there is a pattern where I am multiplying each one by 2. Now, to calculate the rate of change of f over the interval -1 is less than or equal to x is equal to 0, I'm going to use the point -1, 4, and the point 0, 8. And my rate of change is really just my slope. So it's delta y over delta x over that interval. So it's 8 minus 4 over 0 minus -1, which equals 4. Now I want to calculate the average rate of change over the interval 0 to 2. So I'm using the point 0.8 and the point 232. So again, I'm going to do 32 minus 8 over 2 minus 0. That's 24 over 2. And my rate of change is now 12. Notice they're significantly different. What does the answers comparing B and C tell you? That it becomes much steeper. Because the rate of change goes from 4 to 12. So now we're going to draw a sketch of the graph. Now to graph it, we want to use our table. And looking at my table, I see I get fairly large. So instead of going by ones on my y-axis, I'm going to go by twos, but I'm going to skip every other box. So that means every other box I'm going by 4s. I'm still not going to be able to graph everything, but that enables me to graph more. Now, just because I go by 2s on my y does not mean we need to go by 2s on our x's. So my x, I'm still going to go by 1s. So -2 is 2. -1 is 4. 0 is 8. 1 is 16. And that's all I can fit on my graph. But you will see that our curve, and this is a curve, we do not use dot-to-dot lines, looks very much like that. And on our graph, on our calculator, if we hit graph, we can see that it also looks like that. And remember, we could change our window to see larger values. So if I wanted to say go up to 100, you can see that it does indeed continue to go up. Also notice that it never goes across the x-axis. So now we want to state our domain and range. So again, looking at this larger value, I can see that my domain, I can have any x values, so it's from negative infinity to infinity. And remember, when we're writing set notation, parenthesis means it's not included. And for y, for my range, it gets close to 0 but never becomes 0 and goes to infinity. And we can explore more that it gets close to 0 by looking at our table. And if we keep going, you can see that it's really, really small. These are scientific notation, but it never becomes 0. Exponential functions are all about multiplication. The basic form of an exponential function is y equals a times b to the x. That's important. Where the y-intercept, where a is the y-intercept and b is the base of what I'm multiplying by. Sometimes b is known as the growth factor. So in the last one, we were multiplying by 2, so b was 2. So now if I want to graph y equals 3 to the x and find the y-intercept and state the domain. So I make a table, and I can use my calculator to make that table. I then plot points and connect. My y-intercept is 1 because it crosses the y-axis at 1. And here it is in my table. When x is 0, it's 1. My domain is all real numbers, and the range is all positive numbers. Here again, if I do 1/4 x, I make my table. My y-intercept is 1. And my domain, again, is all real numbers, and the range is all positive numbers. So here are some practice problems. So I want you to pause and use your calculator and do your best to try to do these problems. Okay, so I paused and I did these by making a table. From my table, I plotted the points. So my table for this one had x and y. So -2 was 10, -1 was 3, and 0 was 2. And 1, I kept getting closer and closer to 0. Here, again, I made a table on my calculator and I plotted the points. My y-intercept is 2. My domain is negative infinity, infinity. The range is 1 to infinity. Because my range, it gets really, really close to 1, but never actually touches 1. Number 3, again, I made a table on my calculator. My y-intercept is 2. My domain is negative infinity to infinity, and my range is 1 to infinity.